Hello, Algebra 1, and welcome to our third part of our square root mini topic on the square root function. We are going to add another parent function to your repertoire. So you know what a linear function is, you know what an exponential function is, what a quadratic function is, what an absolute value function is, and now we're going to learn what a square root function is, right? Another big day to learn more about functions, right? So here's your general formula for a square root function. F of x is the square root of x. Now, one thing to know about a square root, right? A square root cannot have an input value that is negative. So x cannot be negative. So what that means for the domain, right? The domain x must be greater than or equal to 0. Now in interval notation, that would be a bracket around 0, comma, infinity, parenthesis, right? You're going to see that the range is going to behave the same exact way, because if you plug in a positive number into the square root, you're going to get a positive number out. And the square root of 0 is also 0. So the range is going to be greater than or equal to 0 as well. And again, that would be from 0 with a bracket to infinity, parenthesis. All right, so let's make our picture over here. So I'm going to just use 3 points. So typically, we would go from -2 to +2. But we're going to go from 0 to 1 to 2, right? Cannot be negative, right? And again, we're going to put our function over here. It'll be our y value. So the square root of 0, the square root of 0 is 0. The square root of 1 is 1. Now I put 2 here, but I'm going to change my mind. Because if I take the square root of 2, it's not going to equal a nice number. It's going to be a decimal, so I'm going to cross that out. The next perfect square after 1 is actually 4. Because the square root of 4 is a nice number 2. So be careful. This is the point 4, comma 2. All right, so you're going to see that when we graph it, what it looks like. Okay, so we have 0, 0, 1, 1, but then we have 4, 2. So here's my graph, a little sketch. It's just going to be the first quadrant because everything must be positive. I'm going to go 4 in both directions. All right, so I'll put it in blue here, right? So here's 0, 0. Here's 1, 1, and then 1, 2, 3, 4, 1, 2. And it's a curve, and it looks something like this. And there you go. This is what the square root function looks like. It's a curve. It kind of goes up and then over to the right, and that's it. There we go. So again, all you need is the first quadrant, right? X-axis here, y-axis here, and we call that quadrant 1, Q1. All right, so let's see if we can use this graph to do some translating and graphing, domain and range work, all that fun stuff. Okay, example 1, it says graph the function by translating the graph of y equals the square root of x. Now I'm going to put the general formula for the square root underneath here, right, with all the translation parts, right? So y equals, we can still have an a value, the square root of x minus h plus k, right? So the hk this time is your starting point. So STPT, starting point. This is your h and k. And same thing, because the h is inside the square root, just like it's inside a parenthesis, you always take the opposite of your h. Okay? Now this a is still going to do its 2 things. Number 1, it controls direction. So I know in the general graph, and I'm going to do it right here, right? So we have 0, 0, 1, 1, and 1, 2, 3, 4, 1, 2. Because this is a bigger graph, I'm also going to put the point 9, 3, right? So my perfect squares are 0, 1, 4. The next one would be 9, right? The square root of 9 is 3. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, there's my next point, right? And there's my parent function. So that is the graph of y equals the square root of x. I'll put it right here. Okay, so again, this a controls direction. So right now, this a is going up. If the a was a negative value, it could be going down. Okay, and then number 2, it controls the stretch or compress. We call that the width, right? But here I'm going to talk about stretch or compress. And what I mean is, does this square root go really high up, or does it kind of very little goes up, right? Stretch or compress. But again, that's the same thing as the width that we talked about before. It's just because it's more of a right or left graph versus an up and down graph. It doesn't really get narrow or wider. It stretches up or compresses down. Okay, so back to my original problem here. y equals the square root of x minus 3 plus 5. Notice there's no a value, right? So my a value is a 1. So I'm going to come down here. So that's good. So there's no change in stretch or shrink. But I do have an h and a k, right? My h is minus 3. Take out the opposite. So my starting point is at 3. And then my k is a plus 5, and you use that. So what you're going to do is you're going to take your point 0, 0, and you're going to translate that. Right 3 and up 5, right? Right 3, up 5 to get your new starting point. 1, 2, 3, 1, 2, 3, 4, 5. And now you're going to do the same thing with all these other points too. So we're going to take these 2 points and go right 1, 2, 3, and up. 1, 2, 3, 4, 5. And move this point right 3 and up. 1, 2, 3, 4, 5. So it maintains the same shape. It's just put in a different location. And there's your graph, right? Now, let's talk about domain and range, right? So for this graph, now your domain has changed because this is the point 3, 5. So now your smallest x value is 3, but you can be anything greater because you're going to the right. So x can be greater than or equal to 3. That would be 3 comma infinity with the 3 bracketed because it could be equal to. And then your range, well, your lowest y value is 5 and it goes up. So now your y's must be greater than or equal to 5. So your 5 is your lowest value, but it can be anything above that, so to infinity. And there's the domain and range for this graph. All right, so I'm going to stop the video here. I'm going to make a second video covering the last 2 examples.